All right, we're continuing with 2-2, polynomial functions. Right now, we're going to take all of this information, all right, and we are going to write a polynomial function that best models this set of data. So what I'd like you to do, you've already written this down in your journal, good job. I want you guys to label this one as L1 and label this as L2. Just remember, these are in the set of all of your x values. These are your inputs. These are your outputs. What we're going to do is we're going to make a list in our calculator, and we're going to look at our calculator and help it do a polynomial regression. Is basically what we're doing. So what we're going to do right now, first of all, is we need to set the window that we're going to need. So right now, I'm going to go to what's called window settings. So I want you guys to look at your window settings. So right now, we're going to establish. We're going to look at our minimum x value, our maximum, and the scale. The y minimum, the y maximum, and the y scale. I know, that's a lot of them. So right now, I'm going to highlight the x values, our domain. Let's take a look at it. Of those, what appears to be the minimum?
606.
606. Well, if it's 606, I'm just going to use
605.
no, 600. All right, right here it says 2242. All right, but actually, what I'm going to use is I'm going to use actually 2400. The reason why I'm using 2400 is I'm actually going to change the scale. What's the default scale? The default scale is 1. All right. What I'd like to do is I'd like us to count up by 200s. Okay. The y minimum. Let's look at our y values. Our lowest y value is 133, and our highest is 198. Well, what I'm going to do is I'm going to put a 100. Oh my gosh. To 200. And put a scale of 10. Now, is this the only way you could set the window setting? It's not the only way. For me, this is what I was thinking of to help me have some, I want to be able to see all of this data nice and neat in a certain window. Let's go to the window settings. I'm going to go from 600, 2400, and I'm going up by 200, going from 100 to 200, and we're going up by 10s. Now, let's turn our grid lines on. Second, zoom, turn your grid line from off to on, and when you hit graph, you should see a nice, neat graph. There's nothing plotted yet. Okay, we'll be able to put those in, but that's what you want to see. Let me show you what happens when you mess up the scale. Look what happens. Let's say I forgot to change that to 200 and I made that a 1. Then over here I made the y scale not 10s but 1. You can't even see it. All right. Now, what if I change this to 10? See all those little tiny squares? Change it to 100. Change it to 10. And now you can see it, right? So right here, if I wanted the scale to be 100, it looks a lot better. But I'm just going to change it to 200. Just leave it like that. Okay? If you want to leave it 100, you can leave it 100. Now, to be able to get these points on the graphing calculator, all right, hit stat and enter, and let's type them in, okay? So Josiah, call them out. We got 606.
729 seconds.
Okay.
1121.
1,121.
1,227. 1,318. 1,455, my bad.
1,455.
Yeah. 1,636. 2,030. 2,182. 2,240.
All right. Does everybody agree? Look at my screen. Does everybody agree? Right here, those are the correct numbers. Not type anything wrong. So far, so good? All right. Emily, why don't you tell me the corresponding y values?
133. 144. 157. 171. 175. 187. 193. 198.
Okay. When you guys are doing this, make sure that each x value has a corresponding y value. All right. And remember, these are your x values. These are your y values. Okay. Now, when you hit graph, you still don't see them because we have not yet turned our stat plot on. So right above the y equals, what do you see? What word? Stat plot. So it's second. Y equals. We're turning that on. Your stat plot has to be turned on in order for this to work.
Okay, mine looks something different.
Should say on right there.
So we should apply them. Oh, there we go.
Now hit graph.
Oh, wow.
What do you see?
Plot.
See all those points being what? Being plotted. Okay, so we have it on. Now, to everybody, there's lots of ways that you can interpret this. This could be interpreted as a line. Okay, so if you wanted to interpret it as a line, this would be around here would be the line of best fit. Okay, but this does not say interpret it as a line. It says interpret it as a polynomial function. So we want a function that kind of looks like it does what? It kind of goes through those curves like that. That's what we're going to be looking for. Okay, so we're going to go over the process of how to do that. So, okay, stat. Right arrow. When you want to do what's called a linear regression or a quadratic regression or a cubic regression or a quartic regression, okay? You're going to do 4, 5, 6, or 7. You're going to choose one of those, all right? So right now, just to kind of help us in the process, choose number 4. We know it's not going to be number 4. But choose number 4, and I want you to learn how to store your regression equation. Does anybody remember the go ahead, Raymond.
Y1.
Yes, we want y1 to be there, but how do we get y1 there?
You do alpha y equals.
Alpha trace.
You were close.
Alpha trace.
You do alpha y equals, you can also hit it over, so it gets over.
Okay. So what Raymond was saying was this: you can hit alpha y equals and then move over to the right. You can also do that. Okay, alpha y equals and move over to the right. I'm going to clear that. So right now we have y1. Press enter. Press enter. So this is our line of best fit right here. Now the cool thing about storing it in your y1, now when you go to y equals, look what's already typed in there, nice and neat for you. Your equation, right? So you hit graph, there's your line. Well, that's not what I wanted for this one, because we want a polynomial function. So could it be quadratic? A polynomial, that's quadratic, right? Go down to what? Go down to number 5. Go all the way to store regression equation, but this time I don't want to store it in y1. Where do I want to store it? How about
Y2.
y2? If you store it in y2, guess what it does? You're allowed to do what? You're allowed to compare them. Without having to write all of this, there it is, nice, neatly stored in your calculator. Take a look at it. There's your first one, that's your line. There's your curve. Right now, if I were to choose between one or the other, I'd probably choose the line over the quadratic because the line best fits the data a little bit better. Let's try it cubic. Stat. Right arrow. Let's go to number 6. Go down here. Store. Where am I going to store that?
Y3.
Yeah. Alpha trace. Let's store it in y3. Then we can compare what? y1 to y2 to y3. All right. Thank God I don't have to type all of that in the graphing calculator. That might take a little bit of time. Huh? Okay, graph. First one. Second one. And the third one. You like the third one? All right, third one. I think you're right. Okay. Let's try the fourth one. Okay. Stat. Right arrow, let's go down to number 7. Let's enter, enter, enter. Store regression equation what? Y4. Alpha, trace, 4. I press enter, enter. Uh-oh. Look.
What's you wrong?
Huh. The value entered is not allowed in the function or command. Okay? So basically we have an undefined situation. So we can't interpret this data as a quartic function. So right now, I'm going to say quit. I'm going to go to our graph, take a look at it. Right now we're going to use the cubic function as our polynomial function right now. Okay? So right now, what I'd like us to do is, I want you guys to go second mode, go up in your history to where you had the cubic function, press enter, and enter again. And I want you guys to take a look at this because we're going to interpret what I want you guys to write down for your function. Okay? Now, where students get confused is right here. What does that mean? Okay. Right, 10 to the power of -8. This is 10 to the power of -4. Okay? Now, what I want you guys to understand, if I were to say y equals, and it has ax cubed, how do I write this? What I want you to do is I simply want you to take this right here, round it to the nearest what? Round it to the nearest 100, and put -3.87 times 10 to the -8. That's what goes in front of the x cubed. Okay? Now I'm going to finish this off with using actual decimals and zeros and stuff like that. I'm going to say plus. I round it to the nearest 100. I can say 1.53 times 10 to the -4 x squared. If I kept this in scientific notation, you know what -0.1, we'll call it 0.14, we'll round it, in scientific notation would be? It'd be a -1.4 times 10 to the -1. So we put minus parentheses 1.4 times 10 to the -1 x. And if I wanted to keep everything in scientific notation, that would be 1.67 times 10 squared. So I can say plus 1.67 times 10 we're going to do is we're going to write this all down nice and neat as a decimal. If that says to the negative 8, that means there's actually 7 zeros in front of it. If that says to the negative 4, that means there are 3 zeros in front of it. That's how I always remembered it. 1, 2, 3, 4, 5, 6, 7, 3, 8, 7. X cubed. Plus 0.1230, 153, x squared, minus 0.14 x's, and then I could just say plus 167. Okay. If you wanted to round that, put 0.01, that's fine, but there's 3 significant digits, that's fine. There's your answer. Okay, that's your final answer for writing the model of it. If you would have written it down in scientific notation, that's fine, but if you can just write this down on your paper, that's a good interpretation of this graph right here. Not the first one, not the second one, but the third one. Now the next part asks us to evaluate something. So let's look at the problem. It says to evaluate it.
So that in the box is the number.
Yeah. So right here, it says write the polynomial function. That's the y equals negative 0.1, 2, 3, 4, 5, 6, 7, 387 x cubed plus blah 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 whatever what we had. Okay. Now you have to write it down. I've already written it down.
Plus 0.000153.
0.00015
Plus 167.
minus 0.14 x plus 167. Now, what are we supposed to evaluate? Predict the what? Energy output when the input is what? 800. So basically, when the input is where? 800, somewhere in here. Would you agree that our output should be between 133 and 144? Okay? So if you get an answer between 133 and 144, that's going to be a logical answer. What's one way I could do that?
Okay, so this is question.
So what are we going to do? We're going to put 800 in for x. How do we do that? Here we go. Let's check our table. Where do I typically start, everybody? I start at where? 0. Where do I want to start at? 800. So, second window. All right? If you wanted to, you could go over here to where it says ask. Okay? You could say ask. And then when you go over here, it's like, oh, where do you want to ask at? I want to ask when x is 800. Okay? Now, which answer is the right answer? First, second, or third? Y3. Okay, that's going to be our answer right there. Or you could hit second window, and you don't have to ask it. You can keep it auto. But where do you want to start your table at? You want to start your table at 800. Then you hit second graph, and it still brings you to what? Your answer. So 136.45 would be your answer. Right here. All right. What we're going to do is we're going to look at problem number 8. Okay? Problem number 8 has A, B, C, and D answer choices. Okay? So right now, look at problem number 8. It says we're trying to evaluate this function right here. It says, first of all, we need to apply the leading term test. Now, the leading term test is talking about different functions. Okay? This one is, these are both what? These are both odd, and these are both even. This is a positive, this is a negative, this is a positive, this is a negative. So when it says apply the leading term test, that's what it's asking you to do. So what do we have as our leading term? I'm going to erase everything. Now if you're like, oh, I wish I really had pictures of those, Mr. DeMood. Well, guess what? They're right here. They're on your paper. Okay? I'm going to zoom out just a little bit. This is where it's odd and positive. Here's odd and negative. Here's even positive. Here's even negative. Now, look at your problem. And here, we're going to rewrite this function. Here we go. F of x equals negative x times 2x plus 5 times 2x plus 5 times x minus 3. What did I do a little bit differently?
You factored out the x times x plus 5.
Because if it says it's squared, what does that mean? That means you have to do that twice. So is this an even or odd polynomial function? How many x's do you see?
1, 2, 3, 4.
This is going to be a power to x to the fourth, which means it's going to be what?
Even.
Even. Now, what's the leading term? What's the leading term? Is it positive or negative?
Negative.
So your answer is going to look something like. So remember when I talked about the left-end behavior and the right-end behavior? When it says apply the leading term test, you're applying without even having to graph it in the graphing calculator. I already know what the left-end behavior and the right-end behavior are going to be. Okay? What does x always approach going to the left? What does x always approach? Negative 50. And what does x always approach on the right-hand behavior? Positive 50. Okay? However, if we know our graph's going to look like this because it's even, right, and it's a negative leading coefficient, that means my left-hand behavior is going which direction? It's going down. And my right-hand behavior is also going where? Going down, right? So the limit is going to negative infinity and negative infinity on the left side and the right side. Okay? I realize I'm doing a lot of work up here, but I want you guys to be able to see why this is the answer for A. Okay? You're like, that's the answer? Yes. It says apply the leading term test. The leading term test gives me my left-hand behavior and it gives me my right-hand behavior. Now, answer choice B asks me to do what? Determine the zeros. So what number could I plug in right there to make everything equal to 0? Right there.
Positive x.
How about 0? How about this? What number could I plug in here to make everything equal to 0? 3. And what number could I plug in right there and right there to make this equal to 0? That's a tricky one. Watch this. Set it equal to 0. Watch. There you go. She was trying to say that. Negative 5 over 2 is correct. If you solve this out, okay, what didn't I do? I didn't subtract 5 from both sides. What didn't I do? Divide both sides by 2. Okay? So this is kind of the shortcut. Hey, this is one of your zeros. So what are my 3 zeros? Negative 5 over 2. 0 and a 3. So I could plug in a what? A negative 2.5 here and a negative 2.5 right there. Now, here's the part that you might be confused about. Multiplicity. Any repeated zeros. Okay? What's the repeated zero that happens twice? Negative 2.5. So you would say negative 2.5 is repeated. Okay? And something happens in the graph when it repeats. And we're going to talk about that part tomorrow. Like when you have a zero that's repeated, there's something special that happens in the graph. So right now, to end what we're doing today, I want you to understand we applied the leading term test and we determined the number of zeros by figuring out what numbers, when plugged into this, make this function equal to 0. And the graph of the function is going to eventually look something like this, but tomorrow we're going to go over how to graph everything.